I'd like to show you how to take the complex numbers that we've been working with so far and turn them into a diagram. You can draw complex numbers on something that's called the Argand diagram. And the Argand diagram is very similar to the X and Y axis type of diagrams we've already seen before. The Argand diagram looks like this. It has a real axis here. Instead of an X-axis, it has a real axis. And instead of a Y-axis, it has an imaginary axis. And if you have a complex number, for example, 2 plus 3i, you can draw it on the real and imaginary axis. This is the real part of the complex number, and this is the imaginary part of the complex number. So 2 plus 3i will look something like this. It'll have a point here. And we actually draw them like a vector, like a line coming from the center of the Argand diagram out to a particular point like that. And using a combination of complex numbers, we can start to build up a picture, and eventually we'll be able to draw fractals, or use computers to draw fractals on the Argand diagram. So if I ask you to draw a complex number, it really is just like drawing coordinates. So let's say we had z1 is equal to 4 plus 7i, and z2 is equal to, let's say it says 2 minus 3i, and I wanted you to draw z1 plus z2. So you'd calculate what that is first of all. z1 plus z2 would be these two added together, so that would be 6 plus 4i, and then on an Argand diagram, we tend to shorten that down to RE for real and IM for imaginary. This would be 6 along this way. The real part is always like a horizontal, like the x coordinate. So 6 along this way and 4 along this way. And you would actually draw a line coming from the center of the Argand diagram out to where that point is there. That would be z1 plus z2. And you get some interesting patterns that emerge when you start to multiply and divide and add and subtract complex numbers. There's lots of symmetry. If I asked you to draw, let's say I wanted you to draw a multiplication sum. If I had 4 plus 2i times 2 minus 3i, I'd have to work out what that is first, using first outside, inside, last, like we did last week. So this would be 8 for the first two. The outside would be minus 12i. The inside would be plus 4i. And the last two would give us minus 6i squared. And if you remember, I squared is always minus 1. So I can simplify this to be 8 minus 8i, and then that would be plus 6 at the end there. So 14 minus 8i. And then I can draw it. So the answer was 14 minus 8i on the Argand diagram. That would be 14 along this way and 8 down this way. So that would be the answer we were interested in. 40 along that way and minus 8i. There's a small worksheet. We're going to do some more of this to look at the patterns and the angles involved and the length of the line. There's all sorts of things coming up, but let's just try and practice using the Argand diagram. Thanks.